Input, right. So input, independent variable, domain, horizontal X. They all go together. Are you with me? Those are all names that we've given now to what we used to just call the X. That's the independent variable. So the Y values, give me the other words for the Y value. Output.
Dependent.
Vertical. Dependent. Range. Yeah. Good. Okay. So let's start talking about this. Some of this is just review. This says a relation is a connection between two quantities. A relation can be represented graphically by a set of what? What would we go in there? Say it louder. Ordered pairs. Yeah, let's put ordered pairs in there. Good. And the first component of a set of ordered pairs is what? The X coordinate, also known as the input. And values of the input are values of the what variable? Input and independent. Okay, so when we're talking about an ordered pair, in case you don't know, we're talking about this, right? Like an ordered pair like XY, that's called an ordered pair when it's in parentheses like that. With me, Victor? Okay, so the second component of an ordered pair is the Y coordinate, also known as the output. And values of the output are values of the dependent, right. That's all right. Dependent variable. Okay, so that's all review. And that's super important. You will need to know that information. All right. Consider the following graphs. Let's talk about the X and the Y intercept. Okay, an intercept is like an intersection where it crosses. Okay, so if I was looking at graph 1 and I want to know where it crosses the X-axis, I'd look down here. Okay, down here is where it crosses the X-axis. I'm going to see if I can make this work. So this is the X-intercept. And what would you say it is? What's the value of this point? Negative 3. I don't know why. Okay. I don't know. Somehow I'll have to figure that out. Negative 3 and 0, correct. That blue point is negative 3, 0 on graph 1. Where does graph 2 cross the X-axis? Right here and right here. So if I had to give the values of that, let's give the left-hand one first. Let's do this one over here first. What would you say that the coordinates of that point are? Ben, try. Negative 2, 0. That's right. You always say, how far left or right did I go first? And how about this one over here on the right-hand side? 3, 0. Good. Let's go. You got to be able to name those. I'm assuming that you already know that from last year. Okay, so if that's hard, figure it out. The X value, the left and right value goes first. The up and down value goes next. Okay, how about the last one? Where does this cross the X-axis? Well, right here and right there. Kale, can you name those points? What are the coordinates of your left-hand one?
Would it be negative 4?
Yeah, negative 4 and 0. And the other one would be positive 4 and 0. Okay, so what do all those points have in common? Everywhere across the X-axis, what do they have in common? The Y is 0. Super important, okay? All of them have the Y being equal to 0. So every time you cross the X-axis, Y is 0. All right, now let's talk about all the Y coordinates of this. I'll try to shrink this down a little bit. Tell me about the Y coordinates. The Y intercepts. Where does this graph 1 cross the Y? 0, 5. Notice how we name that? We don't go anywhere left or right. We just go up 5, correct? So we put 0 and then a 5. That means don't go anywhere left to right. Just go up 5. Okay, how about where does graph 2 cross the y-axis? What is this point? 0, 6. Right. Don't go left to right. Just go straight up to 6. You following, Noah?
Yep.
And how about graph 3?
Graph 3.
Where is it? What are the coordinates of the y-intercepts on graph 3?
0 and 4 and 0 and negative 4.
Right. Don't get those backwards, okay? So on the test, I have some kids put those in the wrong way. They go 4, 0 instead of 0, 4. So pay attention, okay? And what do all those have in common? When we're looking for the crossing on the y-axis, what do they all have in common? X is 0. All right, so here we go. If you're looking for the x-intercepts, y is 0. Whichever one you're looking for, you just put the other one to 0, so you can find that. If you're looking for the y-intercepts, where it crosses the y-axis, what do you know? X is 0. So when I say y-intercepts, you say,
X is 0.
say it again, y-intercepts?
X is 0.
Yes, I'll say, if I say y-intercepts, you say?
X is 0.
Okay, my grade 12 class, I'm still doing this. Y-intercepts, and they're saying X is 0, okay? So this is forever. So if I say x-intercepts, what do you say?
Y is 0.
Everybody, x-intercepts?
Y is 0. X.
Okay. All right, I can't tell because we're wearing a mask. All right, so let's go on down to the next page. There it is. To determine the x-intercept. So they want you to get this. If you hadn't figured it out, every time, it's kind of like, you know, when you read your Bible and there's a word that's repeated or a phrase that's repeated, you look for those words. That's because they want you to get the point. There it is. If you want the x-intercept, let y be 0. If you want to find the y-intercept, let x be 0. Get it? Okay, you're going to need to know it. Okay, let's go do a question. Ready? It says, the equation of graph 1 on the previous page is, and they give it to you, 3y equals 5x plus 15. Now, we graphed it. They showed us a picture, and on the picture it was pretty easy to find the x-intercept and the y-intercept. What if they want you to do it algebraically without drawing a picture? Well, when you see x-intercept, what are you going to write down? Y is 0, right? Y equals 0 right there. So you know what you need to do. Y equals 0. So you go into the equation and you write down the equation. Just everywhere you see a y, you put 0. So we start copying this equation down. Ready? We go 3. Oh, there's a y. Put the 0 instead. Equals 5x plus 15. By the way, that's not going to be a 30. That means 3 times 0. Just clarifying, right? Just in case anybody was confused. All right. So we get 0 over here. 3 times 0 is 0. And you must finish solving the equation. First step, Abby. Genesis. 0 equals 5x plus 15. How would you solve for x? Subtract the 15. Right on. So we get negative 15 equals 5x. Next step. Let's go with Ashley. Divide by 5 on both sides, correct. This becomes a 1x equals negative 3. There, your intercept, if it says determine the value, like the coordinates, it would be negative 3, 0. That is your answer. You with me? Are you okay on how we did that? All right, because you're going to have to do this algebraically. Okay, why are we having a conversation? Okay, so when it says y-intercept, what are you going to write down? X equals 0. Now, you're going to have to do this very thing on the first couple of questions of your homework. So let x be 0. You start copying this down. I'm not going to help you on this question on your homework. You're going to get them, and you're going to put your hand up, and I'm going to say, I don't think so. Go look at the examples, okay? I'm not doing this for nothing. So you're going to go 3y equals 5. Everywhere you see a y, you put an x. Sorry, everywhere you see an x, you put a 0. And you end up with 3y equals 15. Next step, Ben.
Take away 15?
No, looking for the y. So see the number in front of the y? Get rid of the number in front of the y. How do we do that? So we're going to divide by the 3. So y is going to equal to 5. So the coordinates of my y-intercept would be 0, 5. Because x was 0, it goes first in the coordinate. And that is your answer. Okay? Right here. Here's your answer, 0, 5. Okay? All right, let's do a little more complicated one. Visitor. Okay, the equation of graph 3, they're going to give you another picture, and it's got x squared plus y squared equals 16. That, by the way, when they're both squared like that, this is a fun fact. When both your x's are squared and your y's are squared, it's a circle. Every time. Kind of cool. And it says, find the x and y intercept of those. All right? Do you notice how they have a little table for you? X intercept over here, y intercept over here. You should do that. When you get to your homework, do you want me to show you? When you get to your homework and it says, right here, question 3, determine the x and y intercepts of each equation. Do you know what you should do? X intercept, y intercept. That's what you should do. This will help you keep organized. Okay? Okay, like, see, these examples aren't given to you just because I like to talk. Okay, this is for you to figure out how to do it. All right, let's go back. So we're supposed to find, it's the circle, and we're supposed to find the x and y intercepts. So when you see the x intercept, what do you write down?
Y equals 0.
Okay, write it down, y equals 0. And then what did we do?
Solve it.
How?
Yeah, you just do it.
What are we going to do next? Everywhere there's a y, you put a 0. So I start copying the equation down. I get to y equals, can I just, okay, 0. Okay, x squared plus 0. Okay, 0. This is nothing there. You can just scribble it out. It's not there. It's nothing. So x squared equals 16. So what's your next step? Square root. Okay. And what is your answer?
X equals 4.
Really? That's all?
No. 4, 0.
Oh, you mean I want to have this? That's all? Look back on your picture. Flip back a page. Look at the circle and tell me how many x-intercepts there are on the circle. There's 2 of them. Why is there 2? What did we miss? How come we only have 1? Let me go back one little step right here.
Oh, because you're square. So then you double it then?
No? Let's just look at x squared equals 16. We're looking for what value of x could you square and end up with a 16. That's what we're trying to find. What x could you square and get a 16? What, Jeffrey? So he's saying there should be 2 answers because it's a perfect square. And what should those answers be?
Negative 4.
Positive 4
Positive 4, negative 4.
and negative 4. Isn't it true that if you put a negative 4 and you squared the whole thing, wouldn't you also get 16? Think about that. Yes. So actually, we have a plus and a minus 4 because if you squared a negative 4, you would still get 16. So you have 2 x-intercepts. You better put them both down or you'll lose marks. You got to give them both, right? Yes, Kale.
Like if you're not doing the bracket one, if you're just doing like x equals 4, can you do it like that? Or do you have to write it like twice? X equals negative 4, x equals positive 4.
Yeah.
Or you can write it like that.
Can you put the plus or minus sign in
Yeah,
front?
yeah.
Yeah, I'll let you put the plus or minus sign in front as long as you understand there's 2 answers. One's a positive 4 and one's a negative 4. Yeah, that will happen every time, people. Like, let's see. Look at this. This is just for fun. X squared equals 49. What's the answer?
X equals 7.
X plus 7. X plus 7. Oh, negative.
No. It's not plus. X plus 7 isn't the word. Do you mean X is going to equal positive 7 or negative 7? Do you understand that? You get it? Because a positive 7 squared is 49, and so is a negative 7 all squared is 49. So every time you have a squared, when you take the square root, you will have 2 answers, positive and negative. All right, let's go back up to the top. Now let's go find the y-intercept. So when I say y-intercept, what do you say?
X equals 0.
Okay, I write x equals 0 up here. Everywhere I see an x, I put a 0. I do the math. I have y squared equals 16. What's my answer? -4 or, and I should say +4. So your roots or your coordinates over here are 0, 4, and 0, -4. Agreed? Y'all good? Okay. Turn the page. Now we're going to talk, how do we put this into a real life scenario? It says Lisa makes a purchase of a new car for $20,000. And you know what happens. You drive the car off. Okay, Kale? Over here. You know what happens when you drive the car off the lot? What happens? Starts losing value right off the bat, right? Drive it off the lot. Unfortunately, it now becomes a used car, and it's usually worth less. So here's the value of the car represented by a formula. $20,000 minus 1250 T, where V is the value of the car and T is the age of the car in years. Now, this is going to be a totally linear decline, correct? Is that what happens in real life? All you car people?
I thought if it had more miles, it was like, that takes one.
So, in real life, wouldn't it be true that it would start to lose a lot of value very quickly in the first couple of years? Then it might kind of level out, right? When it gets to be 8, 10 years, it's not much different. But then as it gets older, it would drop down to some more. And then if you keep it long enough, it actually starts to gain value. It becomes an antique, right? Depends on the condition of the car. So this is not exactly the way the value works, but we understand that what the point is that it starts to decline in value, right? So don't argue with me about how this isn't real, okay? We're all good on it. We understand this is just a question, okay?
Right.
And it says this. So we're supposed to complete the table. So when time is 0, okay, when time has not passed, what's the value of the car? 20,000, okay. So we have this value, 0, 20,000. And let's just go through that right on our graph. So when time is 0 down here at the bottom, it's time going across. You can see it on your page better because it's smaller. When time is 0, we are starting at $20,000. Put your little dot up there on 20,000 when time is 0. It is not passed yet. That's where we are. Agreed?
Right.
Okay, how about after 2 years? How much would it lose in 2 years? 1250 and 1250, how much is that? 2,500. Do you know where I'm getting it? So you just put the 2. Okay, if you don't know what to do, you're going to put $20,000 minus 1,250 times 2. You're going to put 2 in for the T, and you do the math, and what do you end up with? 17,500. Okay, so that's a little spot, 2 and 17,500. And so I could go put that, I gotta go down to the bottom, find out when it's 2. When you're looking at this chart, be very careful about which spot you're on. Like 1, 2, 3, 4, 5. Check your scale. Every line on here is 1 year, correct? So I'm going to go to 2 and 17,500. Okay, how about if it's 4 years? So you would put 20,000 and you would minus 1,250 times 4. What do you end up with? 15,000. So that becomes your ordered pair. We can put that on this picture. And how about 6 years? 20,000, right? Minus 1,250 times 6. What do we get? 12,500. Is that correct? I believe so. And then we have our ordered pair. It all kind of makes sense. You can do this. We did this last year a lot, right? Putting in values for the variable, figuring it out, and then we're going to put it on a table of values here. Okay. Then it says, connect the points with a straight line and extend the line. Okay, so I'm going to shrink this down a little bit. And I have a straight line thing. You would get a ruler. Please get a ruler. Okay, don't eyeball this too much. And I'm going to go from here, and I'm going to draw a straight line. I don't like it. I'm going to erase. Try again. Okay, I'm going to say that's where it goes. It's pretty good, okay? I'm a little off on the bottom. I'm not sure exactly where I went wrong, but we could figure it out. So then it says this. What does the ordered pair 0 and 20,000 represent? Tell me what that, you're going to have to say this in words to me. So give me some words. What does that value, 0, 20,000 represent, Kylie? Yeah. So let's say the value of the car when it's new. The value of the car when it's new.
Oh, so could you say like the highest value?
Sure. But I like to say that when time hasn't passed yet. I like the fact that she said when it's new. That lets me know that time is 0 at that moment. So that's a good, because we want to represent the 0 and the 20,000. Okay, what's next? It says use the graph to estimate the t-intercept. And what does the t-intercept represent? So what do you think it is? Did you try doing this with a ruler? What'd you get? Okay. 15 and a half. Anybody else get something different? 16, and mine's a little over 16. So maybe we'll go with 16. Should we say 16? We're gonna estimate, right? So we're gonna say t is approximately 16. What does that represent? What is t? Time. So what would this crossing right here represent? So that's we're saying it's about like the point 16 and 0. So say it again, Miles. Yeah. So we're saying that in 16 years, this car has no value. Right? So Joey, what's important here, Noah, is that you talk to me about what does the 16 represent and what does this 0 represent. I don't want to say time is 16. That is not the representation of that entire coordinate. Talk to me, what does the 16 mean and what does the 0 mean? Right? You with me? Right. Both pieces. So 16 in 16 years, it's worth nothing. Of course, you could talk to me. Yes, it is. It could be used for scrap. And we have Mr. Alger over here who might buy your vehicle. If
it's probably worth about $50.
Okay. So we understand, though, in the context of this question, we're going to say it's worth nothing. Okay, now here, let's go. Shh. Ready? Malachi, it says, use the graph to estimate the value of the car after 3 years, 10 years, and 14 years. So how could you do that? 3 years. Where do I find 3 years? On the bottom or on the x-axis? So I would go over here to when it's like 3 years. 1, 2, 3. And you could draw your line straight up then. Go right from here and see on that line. It looks to me like it crosses right at 16,000. Would you agree? Right there. You see it?
I think it's 16,200.
Okay, we're going to estimate. So what are we going to say? 16,250? Okay, we're going to round here. We're estimating. How about 10 years? Let's go find 10. So I would go along the bottom to my 10. And I would draw a line straight up. And I would see where it crosses. I get 7,000. I'm going to go with $8,000 on this one. And how about 14? Let's do it one more time. So I go over here to 14. I draw my straight line. Let's go red. I get 3,000. Okay, now it says, use the formula to verify D double I. So 10 years. We used our graph. I got 8,000. Let's use our actual formula and plug in 10 and see what I actually get. So my formula looked like this. V equals 20,000 minus 1250 times my time. So in D double I, I've got 10 years there. You see what I'm doing? Can you tell? So someone do this math for me. Do this. 20,000, it should be 20,000 minus 12,500. What do you get?
Negative 12,000.
7,500, I think. So we were slightly off with our $8,000 estimate, but it's an estimate. Weren't too far off. Should have drawn the line more accurately. Okay.
Is there like a grace with that?
I will never ask you to estimate. I will ask you to calculate. So you better be using your formula, okay, on a test. All right. You can know if you're close by looking at the graph, right? Your graph and your answer should be pretty close. Okay, then it says use the graph to estimate when will the car be worth $5,000. So the value they're giving me is actually the Y value, correct? So I would go up here to my $5,000 and I would draw my little line. I would go across and try to find the when answer. Looks to me like we're at 10, 11, 12, 12 and a half years, 12.5. You going 12.5? Okay. We're going to say 12.5 years. When is it worth half the purchase price? What would that be? 10 grand, right? So when is it worth 10 grand? So again, go to the value of the car, 10,000. Go across. You thinking it's 8? Okay. Oops. Okay, verify with the formula to find out FII, this $10,000 one. We're going to use the formula to do that. So here's my formula. What do I do to verify? Do I have the value or do I have the time? No, they want to know the half of the purchase price. I guessed on this. That's a guess. Don't use that one. So just use your $10,000. That's the given. So where do I put that $10,000? In the V spot, right. Copy it all down. Now what do I do first? Subtract the 20,000 first. We're trying to isolate T. I get negative 10,000 equals negative 1250 T. What do you do next? Looking for T. Divide by negative 1250. Hey, I think we did good on this one. Oh, no, we didn't. What's your answer? $10,000 divided by 1250.
8.
Plain old 8?
Yeah.
Did we do good? Yeah, we did. Pretty good estimate, right? But your equation is what gives you the correct answer. Yes, Malachi.
We've also figured that out because if it's worth nothing at 16 years, then half of that is big.
Right. Only because it's linear? Yes.
All right.
Okay, so we need to write this down. Says the original value of the car is how much? 20,000. It depreciates in value by how much? No. $1,250 per year and has no value after how many years? We said 16. Okay. That's how you're going to use this equations, these graphs, these table of values, this information to actually come up with a good sentence. You could write about this, right? We could say, here's what I found out. Okay, so in this lesson, you need to know this. This is the stop sign guy, and he's important. It says using algebra determines the exact values for the intercepts, whereas using graphs gives an estimate. In lesson 5, we'll use the features of a graphing calculator, but for right now, okay, we want to use your your equations to find the exact. Now, here's a word I want you to know. In part DI, we were asked to use the graph to find the values lying between the given points, and that's called interpolation. Interpolation is when they gave you some values. So they gave you 0 and 2 and 4 and 6. We found those, and then we said, okay, now go find 3. 3 was in between the 2 and the 4 that we actually calculated with our thing, right? So when you're finding information in between the values, that's called interpolation. It's in between. Okay? Get this? Interpolation, scale, is in between the values given in the table. Extrapolation is when you go beyond, when you're exit, outside, beyond the information that you have on the table. We'll see if you remember those words. Okay? Interpolation is in between the data on the table, and extrapolation is beyond the data on the table. Okay, you have some questions to do, go at it.
Huh?